Hi there everybody, I'm Amanda Gordon with the Facial RX here in Spring, Texas. I wanted to do just a quick little introduction to this series of Dermalogica Institute videos. These are not my videos. I did not film these. They come directly from the CEO and instructor of Dermalogica Institute. These videos probably are more than 20 years old, but they do give some great examples of old school techniques as well as techniques that we still use today. I do apologize for the blurriness and graininess on some of these videos. There's not much I can do about that, but these are excellent teaching videos that I just wanted to make sure that are able to be shared and that you have the information in order to properly implement some of these techniques. All right, let's take a look.
Now, let's talk a little bit about this whole process of pigmentation formation, because we need to understand this so we can understand how the Chroma White TRX system is going to address this. We get certain signals in our body, and those signals can be UV exposure, they can be irritation in the case of post-inflammatory hyperpigmentation, it can be hormones in the case of melasma, or even environmental chemicals or medicines that we're taking. And what these, what I call signals, are going to do is stimulate the body, the melanocyte, to make melanin. And this process of melanin formation is called melanogenesis. Now, if we look very closely at, like through the magnifying glass, at this process of melanogenesis, what happens is we see that an amino acid called tyrosine is changed and undergoes several chemical reactions to form melanin, which is the end product of many, many chemical reactions. And this initial step of taking tyrosine and converting it to L-DOPA, which is its immediate reaction that's going to occur, is mediated by an enzyme called tyrosinase. And then tyrosinase takes this L-DOPA and it converts it to dopaquinone. So that's the next step. These two steps that I'm talking about are referred to as step 1 and step 2 of melanogenesis. And really, up till now, those are the two steps that scientists have been focusing on in addressing pigmentation. We know that the tyrosine or tyrosinase enzyme requires in step 2 copper, and this is very important because we now have certain agents that can bind that copper and therefore turn the enzyme off at step 2. We know that once the melanin is made and packaged in melanosomes, it then has to be transferred or deposited into the keratinocyte. And we now know there are certain agents that can prevent this transfer. So we have a lot of different opportunities for controlling melanogenesis today than we did even 3 or 4 years ago. We also know that, as I said, melanogenesis is a multi-step process. We know that these different steps are oxidation steps. So wouldn't you guess, antioxidants will turn off and slow down and stop some of these subsequent steps beyond the tyrosinase enzyme. So we have many opportunities to address this. One of the things we need to address is, why is hyperpigmentation so difficult to treat and treat quickly? And I do want to just clarify this before we talk about the different products. If we look at our epidermis, and we know that our melanocyte is here and it's depositing melanosomes in the cells here, we also know that some of the melanosomes may have managed to creep their way down into the dermis here. Now, what happens with the epidermis? The epidermis is a constantly renewing part of our body. The cells are moving on up and out, and eventually they are sloughed off or desquamated off. When we treat pigmentation, we want to slow the formation of new pigmentation down here in the melanocyte, and that's fairly simple to do. What's not so simple is treating the pigmentation down here, and we also have to take into account that the pigmentation is deposited into the new daughter cells, and it moves its way on up and out through the layers of the epidermis until it's sloughed off. Well, when you're young, this cell turnover time, the time it takes from the cell to be born here and sloughed off at the outermost stratum corneum of the epidermis, can take maybe 14, 20 days. But when you get to be somebody who's like my age, 54, it can be 50 days. What this means is if I'm topically applying something to my hyperpigmentation, I may stop new pigmentation from forming down here, but these cells here already have pigmentation in them. And if my cell turnover rate is slowed down to 50 days, I'm going to be hard pressed to get rid of those cells or get rid of that pigmentation in less than the 50 days that it takes for those cells to work their way on up and slough off. I may address new pigment formation, but I'm going to have a difficult time expediting the movement of these cells on up and out through the epidermis so that I can facilitate or expedite the removal of that pigmentation. That's why a lot of lightening or brightening products on the market have hydroxy acids such as lactic acid and salicylic acid in them, and even retinol to help move that process of desquamation along. There are new ingredients called pseudolanes, which are enzymes that are being used also to expedite the desquamation process. We know that it's only the epidermis that moves cells on up and out and sloughs off, and the dermis doesn't do this. So you have no opportunity, short of really a laser, of removing the pigmentation down here in the dermis. And that's why you may be treating, let's say, post-inflammatory hyperpigmentation, and you may say, I've reduced the pigmentation by 50%, but I can't get that extra bit to reduce itself. That's because it's probably down in the dermis, and we have no way of treating that topically, getting down in the dermis and bleaching it out. It just doesn't exist.